Okay, so we're going to take a look at neon and look at the different, or actually, we're going to look at, yeah, we're going to look at neon as a solid right now and try to explain the different states of matter and do them a little bit more justice than the visualizations you were getting. So just make sure we have the right idea and we're all on the same page. We want to make sure we see the models as we see them. So this is what a solid should look like. If we pause it, if you're asked to draw a picture of a solid, this is exactly what it should look like. A bunch of spheres of particles. We'll just call them particles for now. We won't call them atoms or molecules or anything yet because we'll just treat them as particles. So neon is essentially a bunch of particles together, and if it's solid, they are clumped together. They have little to no energy. You'll notice that the temperature is 14 Kelvin. That is like the coldest thing ever, almost the coldest thing ever. And so it is super, super cold, and they have no energy. It cannot, the so that means that the particles are naturally attracted to each other. So they would rather be attracted to each other, and they don't have enough energy to break apart from one another. So that is why we create these solids here. Now, if we give the molecule a little bit more energy, we will end up making the liquid. So if we heat it up just a bit, I may have gone a little too far, but let's just tap the liquid button. And this is what a liquid should look like. So if we hit the pause button, with the exception of these top ones that have left, right, that are starting to evaporate, um, this is kind of what your liquid should look like. You should just draw circles that are still closely packed together. However, they are not, um, they are, the one key difference is now they can actually move past one another. Remember, as a solid, they were not moving past one another. They couldn't translate from one position to the next. In a liquid, the key difference is they can move and flow from one another. So a good demonstration of that is in motion. So I have traced these two atoms on the right here, okay? And let's see if we can blow that up to make it a little bit bigger. And so we've marked those two atoms. We're going to hit the play button, and it makes you a little dizzy, but you can see how those atoms are now moving around. They're not necessarily next to each other anymore or next to the same ones. And it's kind of random. Now you can tell the dotted lines represent the forces of attraction, or they're still attracted to one another, but they just have enough energy so that they will move apart. So then we get to the gas, and um, they they have so much energy that the force of attraction doesn't really mean anything anymore. So now they're just moving around, bouncing off containers, bouncing off each other, and always in constant motion. Okay. So now the key here is to identify all the empty space in between. That is really what you need to do when you do a gas, and you also need to make sure that you're taking up the entire container when you draw particles in a gas. All right. So I hope that helps and helps you get on the same page for drawing a model for a solid, liquid, and a gas. All right, have a great day.